Welcome back, students. Let's jump into section 4.4, graphs of cosecant secant and cosecant functions. Remember, a cosecant function, that's 1 over sine. So that's 1 over the sine of x is cosecant here. And so we have this kind of pattern where we got these u's and these upside down u's. And if we remember what the sine function looked like, it kind of looked like this. Okay. And so at the maximum and minimum value, we're getting the bottom and top of the u's. Okay, and then where the function went to 0, it's now got some asymptotes here. Okay, and so really this is just like the reciprocal of the sine value. So the reciprocal of 1 over 0 is infinity. It just goes off to infinity. So that's why we have those asymptotes at 0. The reciprocal of 1 is just 1, and the reciprocal of -1 is just -1. But we end up with asymptotes instead of a nice curve, and we have the period is still 2 pi. Okay, but we get these asymptotes at every pi units. Okay, so that's the cosecant function. The secant function, okay, is similar in that it's the cosine, it's 1 over the cosine function. So if we remember back to, well, what does the cosine function look like? It looked kind of like this, right? With one period looking like that. And so again, where we get zeros on the cosecant function, we get our asymptotes. And where we're at 1 on the cosine function, we're still at 1 for the secant function, and where we're at -1, we're at -1 for the secant function. Okay, for the cosine function, where that was -1 at pi, the secant function is also at -1. Okay, so it really does come to us from the sine and cosine functions, but they're inverses of each other. They're reciprocals, I should say. Okay. So the graphs of cosecant bx and secant bx have a period of 2 pi over b. Okay, so the period here is 2 pi. We just get 2 different pieces. Okay, so we get an up piece. We get an up piece, and then we get a down piece, and that's one period. Okay, the up piece and the down piece create one period, and then we go to an up next, and then a down. If we wanted to continue this, we would do a down again, and so forth and so on. And we would get, but the period it is 2 pi, because we don't get everything until we go out 2 pi units. Okay, even though there's an asymptote at pi over 2, we still haven't got everything. Okay, we have to go to the next asymptote at 3 pi over 2 in order to grab everything. Okay, so don't forget that there's an up part and a down part. Okay, the secant or the cosecant, find an interval for one period between the argument 0 and 2 pi. For the secant, find an interval of the period -pi over 2 to 3 pi over 2. So 0 to pi. For cosecant, -pi over 2 to 3 pi over 2 for the secant function. Okay, divide the interval into 4 subintervals and sketch the 3 vertical asymptotes. Evaluate the function at the 2 labeled x values. Okay, plot the points from step 3 and draw the branches approaching the asymptotes. So they're calling these things branches. Okay, this is a branch and this is a branch. Okay, so let's graph some of these. Again, if needed, we need to graph additional periods, we can do that as well. So the graph of 3 secant 2x. So once again, okay, the full secant function would look like this: y equals c plus a secant b times x minus d. Oops. Okay, and so here we have no d or c, we just have a and b. Okay, a is equal to 3 and b is equal to 2. Okay, so again, the period is 2 pi over b, so 2 pi over 2, so the period is really pi. So the divisions that I'm going to have are going to be pi over 4 divisions, okay? So we want the secant, and so where did the secant start? The secant started at negative pi over 2. We're going to have to modify this, the period here. We can still start at negative pi over 2, but we're going to have to modify the period. The period is only pi, not 2 pi. Okay. Okay, so we're going to get this graph here. Okay, we're going to start, okay, at negative pi over 2. And then we have divisions of, okay, pi over 4. So this is negative pi over 4. This is 0. That's going to be another asymptote. This is going to be at pi over 4. And this is going to be at pi over 2. And that's going to be another asymptote. So this is an asymptote as well, and that's an asymptote. Okay, so now we have to figure, okay, well, how does the A affect this? Okay, so the period went from negative pi over 2 to now pi over 2, not 3 pi over 2, okay, because we compressed it. But how does the 3 affect it? And that really is going to tell me where my value is on the minimum and maximum value of my u's. Okay, so the original secant function would be at 1, but we're not going to have it at 1. Okay, we're going to have it at 3, and we're going to have it at negative 3. So if that was 1, 2, 3, negative 3 would be at pi over 4. And so this is going to be a u like so. And this is going to be a u like so. Okay, where this was at negative pi over 4 and this was at 3, and this was at negative 3. Okay, so it's kind of, think of it kind of like the amplitude. It stretches it. It's just, instead of stretching the cosine function, it stretches where we start the secant function. Okay. Okay, let's look at 1/2 cosecant x plus pi over 4. So a in this case is 1/2. B is equal to looks like 1. Okay, so there wasn't any change in the period. The period is still 2 pi. Okay. C is equal to 0. There wasn't a shift vertically, but there is a phase shift. So D is equal to negative pi over 4. Again, remember that, oops, that's a pi over 4. Remember that when we have a positive here, it really is a negative, is the phase shift. Okay, so for the regular cosecant function, we would have started at 0, okay, and we would have gone 0 and then pi over 2, and then pi, and then 3 pi over 2, and then 2 pi. Okay, our amplitude, or where we're starting, is going to be, instead of 1 and -1, it's going to be at 1/2 and -1/2. Okay. So that's kind of compressed a little. It's a vertical compression. Okay, down by a factor of 2. Okay, a factor of multiple of 1/2. Okay, that's half as high. And the period is the same, 0 to 2 pi. But we're going to have this phase shift to the left. Okay, this is to the left, pi over 4. Okay, so all of these values that I would originally be looking at, those values are going to be shifted pi over 4 units. So they're all going to be shifted over, you know, half a division. So if I were to go over here, say 0 minus pi over 4 is negative pi over 4. Okay, then that's going to be an asymptote. Okay, this pi over 2 would have been, okay, is now pi over 4, because it gets shifted over. Everything gets shifted over. Okay, pi over 2 now becomes pi over 4. And so that's going to give me a 1/2 at pi over 4. Okay, and then this pi would get shifted over to 3 pi over 4. The pi would be an asymptote, but it's not anymore. So this gets shifted over to 3 pi over 4. We're basically just subtracting pi over 4 from everything, and that becomes our new reference values. Okay, so there's an asymptote there. Normally the asymptote, if we went up here, normally the asymptote would be at, for this one, it would be at pi. Okay, the cosecant function would be at pi, but we're moving it over, okay, pi over 4 units. Okay. And so this was at 3 pi over 4. That's the pi one. The 3 pi over 2, that would have given me a negative 1/2, but again, I'm moving it over pi over 4. So 3 pi over 2, or 6 pi over 4 minus a pi over 4 is 5 pi over 4. So this is 5 pi over 4. I'm going to zoom in on that. 5 pi over 4, and that's going to end up being at negative 1/2. Maybe I'll raise this up a little bit. 5 pi over 4. And so this is at negative 1/2, is that value there. Okay, and then the 2 pi will get moved over to 7 pi over 4, and that's an asymptote. And so what are we getting? We're getting, I'll put this in black because there's a lot of red on the screen. We're getting this guy here. Okay, and then we're getting this guy here. It's kind of like a parabola, but not really. It's more of a U shape than a UV shape of the parabola. Okay. Okay, last example here. Okay, determine the equation of the secant graph. So this is a secant graph. Okay, so we're going back to the, what did the original secant graph look like? Okay, yeah, that's this guy here. Okay, so it starts at negative pi over 2 and goes to 3 pi over 2. Okay, yeah, okay. So, and there's an up and the down at 1 and negative 1. Okay. Okay, so this starts at negative pi, and it looks like the period is 4 pi, because if I do 3 pi minus negative pi, I get a distance of 4 pi. If I start at 3 pi here, and I subtract off negative pi where I started, that's a period of 4 pi. I get an up u and a down u. Okay, over 4 pi. So I know that the period is 2 pi over b, and so that equals 4 pi. And so what would b have to be? Well, 2 pi is equal to 4 pi b divided by 4 pi. Okay, so b would have had to have been 2 over 4. This is 1/2. So B would have had to have been 1/2. Okay, so that means that the period is twice as long here. Okay, that's good. Okay, and then it's at 1 and -1 still, so that didn't change. Okay, so that's good. So the A didn't change. A is still 1, and B is 1/2 though. Okay, and then any translations? Doesn't look like it. We still have our asymptotes are good. Our everything else. There doesn't look like there's any phase shift or vertical translation. So C is 0, D is 0. So it looks like Y is just going to be equal to that secant of 1/2 X. That's it. Nice. Okay. Okay, thank you very much. I will see you in the next chapter. Good luck on your exam.